أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اقرأ باسم ربك الذي خلق، خلق الإنسان من علق. اقرأ وربك الأكرم الذي علم بالقلم، علم الإنسان ما لم يعلم. كلا إن الإنسان ليطغى أن رآه استغنى إن إلى ربك الرجعى.
Jazakallah. The Institution of Mechanical Engineers, 𝐈𝐌𝐞𝐝, is an independent professional organization that represents mechanical engineers and the engineering profession worldwide. 𝐈𝐼𝐌𝐞𝐝 was founded in 1847 and is headquartered in London, UK. The institution has over 120,000 members in over 140 countries. 𝐈𝐼𝐌𝐞𝐝 TTEC's last student chapter is the first student chapter of 𝐈𝐼𝐌𝐞𝐝 UK in any public sector university of Pakistan. It is the leading technical society of the university, focusing on professional grooming and imparting true technical skills to the undergraduates. It has organized several local, regional, and national events in the campus and has also won several distinctions, both nationally and internationally. Our aim is to equip the students with strong professional, technical, and academic skills. Solidworks Bootcamp is a training program designed to provide hands-on experience and practical knowledge of SolidWorks, a popular 3D modeling software used in various engineering and design applications. The objective of SolidWorks Bootcamp is to provide participants with the necessary skills and to create complex designs and assemblies, as well as to prepare them for the SolidWorks certification exam. The purpose of SolidWorks Bootcamp is to provide participants with a comprehensive overview of the SolidWorks software, its features, tools, and how to use them effectively in the real-world applications. The bootcamp also aims to enhance the problem-solving and critical thinking skills of the participants, as well as their ability to work in the team and communicate effectively. The previous enlightening session was about SolidWorks automation, and today's session is included in the module of SolidWorks surfacing. Let me introduce you all to the speakers of today's session, Saim. Saim is a mechanical and industrial engineer having 5-year rich experience of using SolidWorks in design industry. He's a level 2 freelancer at a Fiverr and currently working as a senior mechanical design engineer at 𝐒𝐿 Company Private Limited. He's a certified SolidWorks expert in mechanical design and a certified SolidWorks professional in simulation, along with other 25 certifications in different areas of SolidWorks and 3D experience. His expertise are design for assembly, design for manufacture, mechanical product design, 3D modeling, and many more. Before handing over the stage to a speaker, following are some instructions you must listen. Participants can turn on their cameras as per convenience. Please have your laptops ready. You should be sitting in a quiet and proper place. And for asking questions, you can raise your hands or you can also ask in WhatsApp groups. So for further insights, I'll be handing over the stage to Ali. Over to you, sir.
Assalamu alaikum everyone. I hope everyone is doing fine. So as the host has already gone through my introduction, so without any further ado, I will be sharing my screen and we will start the workshop. So can anyone confirm if my screen is visible or not? Okay, I hope my okay. So this is a small presentation in which I will go through what we are going to learn in this workshop. So this is the title of the workshop, which is Surfacing and Advanced Design Methodologies. And in the next slide, there's a little bit about me, and but as the host has already introduced me, so I will skip this part and we will move to the contents of this workshop. So what we will be learning today, there will be two modules in this workshop. The first will be surfacing and the second will be advanced design methodologies. So in the first module, the surfacing module, first we will go through what surfacing actually is, where it is used and why we actually need surface modeling, why solid modeling is not just enough for all the design applications. And after that, I will go through some basic surface modeling commands, and then we will do some exercises to see those commands in in action, and learn about how surface modeling is in practical usage, how it is used in design processes. After that, we will start the second module, and the second module is named Advanced Design Methodologies. And in that, we will cover the usage of variables and equations in SolidWorks, configurations in SolidWorks, and finally, we will learn the usage of sketch blocks. So starting the first module, in surfacing, basically surface modeling is a type of modeling in which you are creating surfaces with zero thickness of geometry. Uh, I'm assuming that you all are familiar with some basic concepts of, SolidWorks. So mainly we have two types of modeling in SolidWorks. One is solid modeling, in which we create a solid body. It has a specific volume, and you can apply material and measure the weight of it. And if you cut the model in half, you will see that the model is solid from the inside. And the second is surface modeling. In surface modeling, you are basically creating surfaces which do not have any solid aspect to them. They are thin sheets of geometry in which the thickness is zero and you don't have any solid material there. So where it is used, basically surface modeling is mostly used in combination with solid modeling, because solid modeling commands are not catered for creating some of the complex geometries. So that's where surface modeling comes in. Some of the aspect of geometries which are complex to make with the solid modeling are easier to make with surface modeling. So in general, if I say that surface modeling is a bit more complicated than solid modeling, but it is there to help you aid for creating the complex geometries. Because if you are targeting the same geometry which can only be created with surface modeling, and then you can also somehow create it with solid modeling, but that would be more difficult to create with solid modeling. And some surface modeling commands make it easier to make those complex geometries. And okay, now I think we should go into SolidWorks where all the action is going to be. Let me just share my SolidWorks screen and we will get into the commands and see how it works. Okay, so my screen should be visible now, and you should see SolidWorks opening screen right now. Okay, so on the top command tabs, you can see that we have basic features, which whenever someone is learning SolidWorks, he starts from here. And we have certain different tabs. There is the surfacing tab. If you don't see the surfacing tab on your PC, then you need to right click on the on these tabs and go into the tabs menu, and there you will see several different tabs which are normally not visible, and tick this surfacing one. Then you will see all the commands related to surfacing. Okay, now let me make a basic sketch. So I will start with a circle. So now we have a sketch here. I will not be going into the details of sketching and how I am completely defining the sketches. But for that, you can go through different workshops and also ask in the Q&A section at the end, or just reach out to me on LinkedIn personally and we can talk about different stuff too. So right now I'm giving some basic dimensions to this. So now we have a circle. Okay. So the most basic surfacing command is planar surface. A planar surface is just a two-dimensional plane surface which is bounded by a specific boundary. If I click the planar surface, choose our boundary, then it will create a surface in the shape of that boundary. So now we have a surface which has 0 thickness, and it is enclosed by that circular sketch that we created. Okay, so that's about planar surface. Now let me just get rid of this, and now we will learn about the extrude command. So extrude command is actually the most basic command when it comes to solid modeling, and it is similarly used in surface modeling too. It just extrude a sketch. By default, it extrudes perpendicular to the sketch plane that we are making, and just extrude the sketch that we have made into one direction. But when you apply this to solid modeling, then you will have a solid body, a cylinder here. But when we apply this in surface modeling, then you will have a surface of 0 thickness. So this is about extrude command, and you can also play around with different properties of extrude command. You want to extrude from the mid plane, then it will extrude equally on both sides. You want to have a draft angle on the inside or on the outside. If you click draft outward, it will draft outwards, and this will be your basic extrude command. Okay, so now we will move toward the next command, which is the revolve command. So for a revolve command, I will make a different sketch. Let me just have a center line around which we will be rotating our geometry. Let me create a basic sketch, something like a vessel or vase. In the sketch with some basic dimensions. 20 millimeter over here. We'll add a horizontal constraint on these 2 points. So the most important thing when it comes to modeling, according to me, is defining your sketches. If your sketch has any blue lines, it means that it is not completely defined, and when you want to move, it can move. And if you click some of the blue geometry and move it around, you will see that this is the degree of freedom that I need to remove to define the sketch completely. So right now you can see if I move this point, it is only moving horizontally because all the other aspects of the design are constrained. So I need to constrain this degree of freedom to make sure that my sketch is completely defined. To make sure that this is defined, I will make it coincident to this line. And now this one is not defined, you can see. So I will give it a dimension right here. Let's say we give it 45. Now the sketch is completely defined. Now we will go to the command revolve surface. You can see that it automatically detects the axis around which it is supposed to revolve, and it will create a surface body by revolving our sketch around that axis. You can also play around with the properties of the surfacing of the revolve command. If I do not want to revolve a complete circle, let me just make it 90. It will just make a surface like this. Yes, pretty simple, right? So these were our most basic commands, the extrude and the revolve command. You will find these listed in the solid modeling also. So now let me see which commands are we gonna do next. Okay, so I will explain these commands a little bit in detail. The delete face and the delete hole command. So in Solidworks, you have pretty interesting commands which can help you remove some complexity from your model. For example, when you are working with a surface and you do not have access to the design tree, and you are supposed to work with some step file or something which you do not know that how the design is going around, and you cannot edit it anywhere, you can use these direct editing commands to play around with that model. For example, I will make a hole into it. I will also explain the trim command and the delete hole and delete face command here. So let me just, I have made a circle here. Now if we go into surfacing, we can see that there is an option to trim surface. So what this command will be doing is it will be trimming this surface with this sketch. It will just remove this area of the surface based on what I'm selecting. So now you can see we have a hole here. So if you get a surface like this from a step file and you do not have access to the design tree, you don't want to go into the hassle of figuring out that how this surface is made, where it is defined, and to fix this hole, you can just go to the delete hole command, select the periphery of this hole and tick it, and the hole is gone. You can use these methods to fix the geometry of models that are not in your control entirely. And now I will go through let me apply a small fillet here to explain the next command. Let's say we have a fillet of around 25 millimeter here. Okay, so now the surface looks beautiful, but if you do not want this fillet, and this is from a model that is not in your control, it's a model completely from a third party or something, and you want to have the edge before the fillet was applied, then you can use the delete face command. So what the delete face command does is, if you just select delete here in the left panel and select a surface and apply the delete command, then it just gets rid of the surface that you selected. But the interesting thing is that when you apply delete and patch, then it deletes that surface and patches the surfaces that were connected to it. It automatically extends those surfaces to meet with each other so that your geometry is not affected, and you can use this command in solid modeling also. So that was about delete surface. We have covered trim, delete hole, and now let's see how the untrimming surface works. Now if the surface is not only trimmed around this but also around this part, we have a cut of 15 millimeter by 10 millimeter here. So you can see this part is also gone, and you want to recover this part. You will select the untrimmed surface, give it the edge that you want to recover. It will automatically detect that okay, this surface is missing and we need to untrim it. You want to click OK, and this is how it will fix the surface. So that was about the untrim command, and now we will move forward to the next command, which are sweep, lock, and boundary surface, and etc. So I'm going to make a new sketch for the sweep command. Let's make a sketch. This will be the profile around which, this will be the path around which we will sweep a profile. Let me just define it real quick. This is our path sketch, and now we will have a profile sketch right around here. Let me just make a circle, give it a diameter of, let's say, 15. There we have a path sketch and a profile sketch. And if we go into the sweep command and we select this profile and this path, then we will have a sweep command which is quite similar to the one we have in the solid modeling aspect of the sweep command, but you will see that it is hollow from the inside, and if I section it, you can see that we have a zero thickness surface here. So this is This one is quite similar to the one that we have in solid modeling. So let us have a different type of profile here. If I edit this sketch and I make an open contour here, which is just a line. And let's make it horizontal. When your sketch is completely black, it is a sign that the sketch is completely defined, and if there's something blue, then you need to find out which part of the sketch is not defined and apply some certain constraints or certain dimensions to it to make it defined. Okay, so this is where the surface modeling is different from the solid modeling aspect. So in solid modeling, we won't be able to sweep it around this path because it will say that it needs a closed contour. So if I make a surface out of it, then it can be done. So it eliminates a lot of complexity from your design. It makes several things easier for you. You don't need to worry about the zero thickness geometric problems and things just not fitting in when it comes to solids. So that's where surface modeling is actually simpler from solid modeling. And one of the interesting things shows up when I am able to twist the path. Let me just apply a twist of revolutions. You can see it creates a very interesting form of geometry. And as I mentioned that the surface modeling is mostly used in parallel with the solid modeling, and it is our eventual goal is to create a solid body, because otherwise you cannot manufacture anything with zero thickness. So if I want to apply a thickness to this surface now, I will use the thicken command, and let's say I apply a thickness of 1 millimeter. We can choose the direction of thickness. From here we have three options. We have this direction, we have the opposite direction, and we have the mid direction. So when selecting mid direction, it will do 1 millimeter on both sides, so the total thickness will be 2 millimeters. So yes, these type of interesting geometries can be created with surfacing, and they are way more difficult to create with solid modeling. It is possible, but it makes the process very complicated, and the modeling is mostly unstable, and it is very likely that you will get errors when you're changing your model. So now we have also covered the thicken command. Now let's get rid of this also. Now we have the loft command, which is considered one of the complex commands when it comes to solid and surface modeling. So let me just create a sketch on top plane. Let's create a construction line here, and after that we'll get an arc here. It's coincident. This, and now I will apply a symmetrical constraint to these 2 points. So what this constraint does is it has made this and this point symmetrical around this axis, and if I move this part, the other part will move similar to it. Now let's say 45, and let's give this a dimension, and now the only thing which is left to be defined are these endpoints. So let's give a dimension of about 40 millimeter. So now we have one sketch here. Now let's go to the right plane and create another sketch, which will be quite similar to this one. So I'm making these sketches to actually explain the loft command. Let me just define it like we did in the last one. 20. Let's make this. Let's change this actually. 60. And now if I give one dimension here, it should completely define the sketch. But yes, these are not symmetrical yet. So I will apply a symmetrical constraint here. Okay, if I'm going too fast, then you guys can always raise your hand and stop me and ask any question if you feel like, okay? And if the host is there, kindly let me know if there are any raised hands or any questions from the audience so that I can stop and answer it before moving forward. Let's change this dimension, and now we will apply a loft command between these two faces. Let's choose the loft surface. I will choose the first profile and the second profile, and it will just bind these two profiles to make a simple lofted surface. And now the interesting thing is that you can apply starter and constraints, which are most famous is the normal to profile. So what this constraint does is it makes sure that when you are creating a loft command and you are joining two surfaces like this, then it starts with a curvature or with a tangency to the plane on which we have drawn the sketch. Okay, so we will apply the same on this end also. And now if I click OK, then you will see that we have a beautiful looking surface here. Okay, so now I will go through the boundary surface. So what the boundary surface does is you're supposed to give it a specific boundary and it creates a surface by joining those boundaries. So if I give these two boundaries and its direction is not fine, so I will take this green line, and I think there has to be an issue. Yeah, it's taking the edge as opposite, so let me just try to fix that problem real quick. Yeah, now it's fine. So what it did is it creates this line as a boundary and this line as a boundary and creates a surface between those two lines. So now we have a plane surface here, and if I go into the section view, you can see that we have two surfaces, one that we lofted and the other one as a boundary surface. Now to go through the fill surface command, it is somewhat similar to the delete whole command, or in terms of the use that I'm going to put it here, but you will see the difference when it actually happens. So let me just create a hole in the lofted surface that we created for construction. Now defining the sketch and a diameter of 50. So now let's create a hole in this lofted surface. And how we are going to do this? We will use the trim command. This one will be the trim tool and this one will be the surface that we are going to trim. So if we hover onto the surface, you can see that it shows you the different sections that it is trimming. So if I'm removing the selection, I will select this surface and click OK. Now we have a hole in our surface which we created with the loft command. Now if let me just hide this one. If I choose the fill surface command and give it this boundary, it will fill the hole with the surface, which is not completely tangent to the boundary that it is supposed to be on. You can edit those settings manually, but if I section here, you can see that there is a specific curvature difference between these two. So right from here, it has a specific curvature, Here it also has a specific curvature, but this one seems pretty flat. So if I edit this and I apply a curvature constraint to this so that it maintains the curvature of the surface from which it is connected to at the boundaries. Okay. Now it will almost have the same curvature, and if those two surfaces are joined together, you won't notice a difference here, and you will feel that this is completely actually a single surface. So that was about field surface command, and now we have the most interesting command in surface modeling. So one of the most powerful things that you can do with surface modeling is you can convert a surface into a freeform surface. And what a freeform surface is that it takes a surface, it divides it into a grid. Let me just show you. There you can see the freeform command. And if you select a surface, you will see that it divides it into a grid of different sections. Okay. Now I will add a curve in the middle, almost in the middle, and after this we are supposed to add points to this curve that we have added. And now is the most fun part. Now if you select a point, you will see that it is giving you a specific option to move this point around in 3D space, and if you move it around, you can see the surface will move with it. And this is the closest thing in solid modeling that comes to wireframe modeling or organic modeling, which is a completely different field. So this gives you way more freedom over how you want to edit your surface. You can add multiple curves, you can add multiple control points, you can move them around to get a surface of how you want it to be. If I go into the section, you will see that this line is this line is deformed as compared to the sides because we converted it into a freeform surface. So this is one of the most interesting commands in surfacing. Okay. So now let's finish up with the commands here. Let's just cover the offset surface and the rule surface. So what offset surface does is it takes a surface and it offsets it into along the normal of the surface to a specific direction. If I change the direction, you can see that this is up to where it will offset the surface and it will create a new surface for you. So this is also one of the most interesting features of surface modeling that you cannot get with solid modeling. Okay. And for the rule surface, if you have a boundary of a surface and you want to extend it normally or tangentially to the surface, then you can do it with the rule surface. There are a couple of different options too, but the most commonly used are tangent to surface. If you click tangent to surface, you can see that it is creating a surface which is tangent to it. And if we create normal to surface, then you can see that it is creating it normal to the tangent of the surface. So this is the rule surface. And let me see if we have anything else to cover. I think we have gotten almost everything. Only the one of the finishing commands is left, and that is flat surface. Let me just delete the commands that we are not going to use here. And suppressing the boundary surface. So you see we have this boundary surface here and this lofted surface here. And if you go into the surfaces menu, you will see that we have two different surfaces and it is not treating them as a single surface, which can be further used to do different things at the edges, apply fillets and manipulate the surface as a single surface. So for that reason, what we need to do is we need to knit the surfaces together. So when you are knitting the surfaces together, the surfaces need to touch each other at the edges. If I knit them together, you can see that before I applied this command, these edges were blue. The blue edges represent that a surface is ending or starting from there, like these edges. but we don't want to end this surface here, and we want these two surfaces to be treated as a single surface. So if I apply the knit command, you can see this edge is converted to black. And now if I wanted to apply a fillet on this edge, let's say a fillet of around 1 millimeter, then you can possibly do that. See, one of the other features of knit surface is that if the surfaces combine to form a closed geometrical space, then you can also convert your surfaces to a solid inside that knit command. For example, if I create two planar surfaces, if I select this boundary and this boundary, it will help me create a planar surface between these two. So now this open end is closed, and now creating another planar surface, we have this end also closed. Right, so now if I join these surfaces, they will create a watertight geometrical space. But right now there are four different surfaces. This is 1, 2, 3, and 4. So if I knit them together, if I added the knit command and give it the two additional surfaces that we created too, then you can see this option to create solid would be available to you. If I take this option, you can see now we have a solid body, and if I section it from the middle, you can see that it is solid from within. So yes, these are the two commands that are used to convert a surface to a solid, and one of them is knit command, which is used to convert a closed space into a solid body, and the other is thicken command, which is used to give a specific thickness to a surface, saving you from the hassle of making it with solid modeling. If I convert this, for example, to a solid body, you can see the only top surface is given a specific thickness and converted into a solid. So either you have to do surface modeling and then eventually you can convert it into a solid body, or you can use surface modeling in combination with solid modeling, so that you can use surfaces as a reference, and you can use it to aid in your solid modeling process. Okay, so now let's go through some exercises which will explain the uses of the surfacing commands. Okay, so I think we are also running out of time, so I will be doing only one exercise here. So this is the exercise that we will be going through. If anyone wants to take a screenshot, or I will send this to you afterwards so that you can follow along. Let me just get it to the other screen and now open a new part. So the thing we are going to do here can probably also be done with the solid modeling, but right now we are doing it to show how these commands actually work in action. So right now I will create this line. I will give it the dimensions that are given in the drawing, 95.5 here. I will give it an arc. Just speed through the process so that we can get there in time. Line some reference lines over here and here. Now I will give the dimensions to these reference lines, 100 degrees and 1. Now for the dimension, you can see in the top view that we have a dimension of 33 over here, and also over here. Okay, I think I should just send this in the chat of this meeting so that if anyone wants to open it on their end, they can also do that. Okay. Okay, I think it shows me that only the team members can message in the chat. So I will send it to the host or someone managing the meeting, and they can send it in the chat or provide you the file afterwards. Okay, so let me just go through the exercise. Now we see some specific curves here. You can see this curve. This is actually made of 3 different arcs. So we just need to make 3 arcs here and define them according to the dimensions that are provided. This is the first arc, this is the second one, and this is the third one. Now let me just define these real quick. 25, 30, and we have 50. And we have a constraint here which is not supposed to be there. Let me just remove it so that this curve can also move around. Now the final 2 dimensions are from here, 47, and from here, which is 65. Now we have 2 control surfaces for the loft command that we are going to apply here. Now let's just create 2 surfaces on which we are going to get the profile. I will select this and this one to create the first surface, and then this and this to create the second surface. Now on this surface we are going to make this profile 33 by 25, an ellipse, not too difficult. Let's just select an ellipse, and okay, it's the other surface. Let's just make an ellipse here to give it a dimension of 25. For the second one, we need to make a sketch on this. Let's make an ellipse here too. And right here we have the dimension of 28. So now we have the profile, we have 2 control surfaces, but we need 2 more to actually, you can see on the first page. Let me just show you. So we have these radius also, which is 330-degree radius from the sides. So for those I will need a custom plane. First of all, I will select these 2 points and the front surface. So there we will have our reference surface on which we will draw the control lines. So I just need to give it a dimension of 330, and it's completely defined. Now let's just mirror it to the other side. Let's mirror it around this midline, and now we have all the sketches that we need for it. Okay, so now I'm going to apply the surface loft command here. So I will select the 2 profiles, and after that we are supposed to select the guide curves. So we have 4 guide curves. One is this, and the other is a combination of this, this, and this line. Now giving the side ones, this is one and this is one. So now here our lofted profile is ready, and these sort of aesthetic curves are easier to draw in surface modeling than they are in solid modeling. So Let me just make two planar surfaces, one here and the other one here. And now if I select knit command and select these three surfaces, I will have the option to create it into a solid in here. So this was the exercise for surface modeling. Now let's jump into the section of advanced design methodologies, in which first we will cover the usage of equations. So for equations, you can I can explain it as like if your design is driven by some specific equation, like this side is multiplied by 2 to create this side and the length is twice as long as width or anything like that, then you can create some variables and define some equations inside SolidWorks, and SolidWorks will keep track of that. So let me just go through some very basic exercise. So to access equation, you will need to go into tools drop down menu, and there you can find equations. So right here you can make global variables. Let's say we have a, the first variable is a, and a is 20 millimeter. And then we will create another variable which is b, and b is 30 millimeter. And then let's say we have another variable which is 10 more than a, and we will write in double quotes, we will write a and plus 10 millimeter. You can see we have 30 millimeter here, and if I change a to 10, the other one will like update itself. Let's use this. Let's see how we can use this inside our design. So we will draw a sketch on top plane, and we will draw a simple rectangle. And when you give it a dimension and you click equal sign, then you will see you have the option to apply global variables, functions, or file properties. So in global variables, I want to give this a dimension which is equal to the variable that we created, which is a. So if I click a, you will see an equation sign which describes that this dimension is driven by a variable. Okay, and if I apply a dimension here and I want to keep it equal to the variable b, then I will select b and click OK. Then you can see this rectangle is defined based on the variables that we defined previously. All right, now I want to extrude it, and to extrude it equal to the variable that we created, c, which is in turn connected to the variable a. So if I select c here and click OK, then it will define it as being extruded 10 times more than the variable that we defined, which is a. Now you can create, if you want to access equations after generating variables, you can access them from here, which is manage equations, and we have here like all the variables that we created. If I change it to 15, we'll see the design will update in real time. See, it changed all the values that we have changed in the equations. Okay, so that was the use of variables and equations for modeling. Now let's see how we can generate configurations. Okay, so if I delete this, you will get an error here because the variables that we defined are missing. So you just delete it from here and it will be fine. Delete these two and manage equations. Delete this. Okay, so now we have a clean design tree. Let me create a part in which we are going to revolve a specific piece of geometry. So configurations are basically used to make different parts which are similar in their design intent, but you don't want to make separate parts for them. For example, if I have a circular part right here which has a diameter of 10, let's say it has a thickness of, let's say, 8 millimeters. And another important thing is you can directly use equations without creating variables through this method. If I want to keep this thickness equal to this thickness and want to keep them connected, I will just click equal sign here, and instead of going into global variables, I will keep my cursor here and click on this dimension. This will connect these two dimensions and make sure that if I change this one, the other one changes as well. So in this way you can make the use of equations within your sketch without having any global variables. Let me give it 20 here and 30 here. So let's revolve this part. Okay, so now we have a part here, and let me create a series of holes in here. Let's create a hole with a diameter of meter and a distance of, let's say, 25 or 26. You can see that this is the only degree of freedom that is remaining. So if I give this a constraint of being horizontal in this point, then this will be completely constrained. Now let's make a hole here, cut through all, and now we have one hole, and I want holes all around it with a specific amount of holes that I need. Let me use a circular array. The features I want is this one, and the direction is this. So now let's have 6. So now we have a basic part here. Let's just give some fillets. Diameter fillets here and here, so that it looks less boring. So now I will tell you how you can create different configurations of this part. So you are designing a part and you feel like that you need another similar part which is similar in shape, but it has different dimensions and different amount of holes or anything. So I will go into this tab. You can see right here the property manager, and inside the property manager you have configurations. If I right click on it, it will give me the option to add a configuration. So let's see, I am doing a version 2 of this part. Okay, so if I am changing any dimensions here, let's say the version 2 is going to have a different thickness, let's say 6 millimeter. So one thing you need to notice is that if I am changing the dimensions here, there's a small sign right next to it which says all configurations, which means if I'm going to change this dimension, it will change the dimension in all configurations. And if you want to keep the changes only in your current configuration, then you need to come to this drop down and select this configuration. Now if I change the thickness 6 millimeter, the dimension is changed and it will only be changed in this configuration. Let's say we change this one also. We have a thickness height of, let's say, 40, and our version 2, let's say, we have fewer holes. So this can be a little tricky, but you don't need to actually go into this command. You can just click here and it will show you this small variable 6. If you double click on it, it will give you the same dimension changing menu that we had inside our sketch. So let's say we are only changing in this configuration and we have 4 holes in this configuration. If I rebuild, you can see we only have 4 holes now. So now we have a new configuration. Let's see how we can get our previous configuration back. So If I double click on our default configuration, it will take us back to our previous design, and the version 2 that we created is still there in the form of different configurations. And another thing I would like to mention here is if you are making an assembly, let's say new assembly, and you have one part but different configurations for it, then you don't need to worry about exporting different parts inside it. We need to save that part before I'm able to insert it into an assembly. Let's say we save this as part 3. Now if I insert the component of part 3 into here and I click OK here, if I click this part, you can see there is a little drop down here which asks me that which configuration am I supposed to put here. If I want the default configuration, I will click default and click the tick mark, and it will give us this part. And in the same part, if I create a copy of it and I want the different configuration of this part, then I will select version 2, and you can see we have both the part driven by one part file in the form of different configurations of this part. So this technique is used when you are supposed to create a lot of parts and you don't need to create a separate part file for each part or model name. You can create like hundreds and thousands of variation of a single part if possible. So that was about configurations. Now let me show you something about let's just create another configurations to demonstrate one more thing that I think I skipped. So if I add a configuration named version 3, I want a version 3 of this part, and in this, along with changing the dimensions, let's say we have a 60mm long part with 25mm wide. Okay, excuse me, I'm supposed to select this configuration only here. So with a 25mm wide base. And the thickness, let's say in this one will be 5mm. Okay, and in this part I want that there should be no holes, and I don't want this command to actually be in this configuration. So if I right click on this part, on this command, and I click configure feature, then you can see I have the option to suppress the command in some specific configurations. Okay, so I want to skip this one in configuration 3. Okay, so I will suppress it, and you can see if I go to the other ones, we will still have holes, and if I go to the third one, it will not have holes. Okay, so if I go to the assembly, similarly I can just take another piece and make this one version 3 and click tick. So you see we have 3 different configurations of the same part in a single part file. Okay, so now coming to our last module, I want to show you the usage of sketch blocks. So what sketch blocks are, they're like a sketch inside a sketch. It creates a sub sketch, you can say. If I create a sketch here and you are at the initial idealization of a product and you want to see whether your mechanism will work the way it is supposed to be or not. So let's make a 4-bar mechanism. This is how a 4-bar mechanism looks like. So if I am telling someone who is a beginner at Solidworks to make something like this, he will think that he will create different parts and then he will make an assembly and then show me that this is how it is rotating, these are the degree of freedoms, and you don't need to go through all that if you need only visualization of your mechanism or your product. So we can do it all inside actually a one sketch. So let me just create a basic link here, and Give it some dimensions. Let's say it's 100 millimeter long and it has a radius of 3 millimeters. And now if I want to make this into a sketch block, I will click on this slot, and there you can see there is a small option to make it into a block. Okay, so if I click OK here, you will feel like that you have come out of editing the sketch, but that is not the case. It's just that it has created this into a sketch block inside that sketch. So let me just create some more, and you can see we will be able to move it around in 3D space because it is now a sketch within a sketch. And to constrain it, we need to apply the same principles. I need to make it coincident to here, and it will be able to move around in a circular path. So if I make this horizontal, now it cannot move. And you can also copy and paste a sketch if you want multiple sketch blocks with the same geometry. So if I select the sketch block, press Ctrl C, Ctrl V, you can see we have another one. And if I change dimensions in this one, let's say I give it 120, the other one will also change along with the old one. So I'll just make it 100 for now. And we'll delete this copy because we don't need it. And now we will create another sketch block right here. We'll give it a dimension of 30 and radius will be 3 as previous one. Now click this, make it into a block. Okay. Now if I constrain it to this axis, you can see I can move it around. So it kind of feels like that it's working in the form of a mechanism, right? So let me go to the interesting part. Let's create another one. And let's give the dimension of, let's say 70. Be like 60. And the radius will be 3 like previous ones. And now let's make it into a block. Now this is also a block, and we will make it coincident to this end. So now you can see we have two links which are moving independently to each other. And the fun part begins at the next link. Let's say we have another one which is equal to almost 90, and we have a radius of 3. I'll make this into a block as well. And now if I make this coincident to this one, this will kind of act like a robot arm. And when I make it coincident to this one, okay, so now if you move this part, you can see the other one will move around in the form of a mechanism, which is a 4-bar linkage mechanism. And you did not need to make any additional parts or any additional assemblies to create this. You can go on and you can make it more complex if required. You can add multiple different joints here, give them constraints and move it around to see how your mechanism will move when you are creating a product from scratch. You are at the very initial stages of idealization in your product development cycle. Okay, so we have another block, and let's create some construction lines. Let's say I want to keep this one coincident to this line. Let's give it some dimensions, 70 and 30. Now if I make it coincident to here, and this one coincident to this line. Now if I move this, you can see the part is moving in that linear direction that we applied the constraint to it for. Okay, so these were the topics that we were supposed to cover today. I had one other exercise for it. Is the host still in the meeting?
Yes, I'm here.
So do we have any more time for the session, or should we have questions now?
Uh,
The session goes to up to 3:30, right? But I also wanted to leave some time for questions. So let me know if we can possibly cover another exercise or not.
Please wait, I'll confirm you.
Okay. Okay, so meanwhile, we will play around with this mechanism and see what we can do. So you can see it gets stuck at a specific point because it is being pulled to its extreme position. If I move slowly, you can see that it will not move past this point. So this will give you a pointer that if you are creating a mechanism with these dimensions, you will not be able to make it in a way that it will go through the complete circle, and you did not need to make different parts and make different assemblies, then edit parts to go through all that process of confirming whether the dimensions are appropriate for the design or not. You just did it inside a sketch. So if I edit this dimension now, let's say we have 45, and now if I move it, it will go into a complete circle. So you can use these methodologies to actually make your process of product development much simpler than it is. Okay, so I think to save time, we should go through some parts which are already made. We just open some parts. Okay, this is, okay, let me go out of the sketch. No. So this is one of the parts that is like very difficult to create with solid modeling. You need to shift to surface modeling to create a complex geometry like this. So I will take you through the process of how I did it. So first of all, we have a sketch on a plane. I will also show you the drawing for this part. Okay, so this is the drawing that I used to make this part. You can see that it is almost a 2D surface, but it has a specific thickness to it. So the first thing that we noticed from this drawing is that we can simplify our process by creating a 2D sheet and eventually giving it a thickness. Okay, so we don't need to worry about the thickness at each point in our design process. So first of all, I created a sketch here, and then I extruded a surface from it like this. Okay, then I created a curve. I created a sketch on top plane. You can see this is a flat sketch, and the dimensions are all given in the drawing. And when I use the command of making a projected curve onto the surface, it projected that sketch onto this surface and gave me this curve, this blue curve. And after we have created a projected curve, we can use it to make a sweep command. So I used this sweep command. I selected this projected curve as a profile. I did not need a specific sketch profile because in sweep command you have by default an option to create a circular profile. So it just creates a circle by keeping the profile that you are selecting in center. And after this we have a swept surface along the path that we created. After this, I trimmed the bottom of the circular surface by using this as the cutting tool. Then I used another trim command to get rid of the surface in the middle. And now as you can see that these surfaces are touching at the edges, we can use a knit command. So when I knit the surfaces, it joins these edges to create a singular surface. And after that, the only step that was left was to apply a thicken command and give it a specific thickness. And if you try to make this geometry with the solid modeling approach, then you will run into different issues at different points, and it will not be as easy as it was with the surfacing approach. Okay, let me just go through another example here. Okay, I think I need to open it from here. We have part 1. Okay, this is the one that we need to close. Okay, so this is the part that we created initially, this one. So I was just messing around with it, and let me show you what are the possibilities that you get when you are working with surfaces. So after knitting it, you get a solid surface, right? It is solid from within. And now if it is supposed to have a covering around it, a plastic or silicone covering, so what we can do is we can just offset a surface from here. I selected this surface and I selected an offset of about 1.5 millimeters. Then I drew a sketch on the side plane and I trimmed the surface from top and bottom. Okay. And after that, I applied a specific thickness to the part and gave fillets on top and bottom to make it look more beautiful. You can see now it looks like that it has a very beautiful covering around it, and this type of thing is very easy to do with surface modeling and quite difficult to do with solid modeling. Okay, so now let me just go back to the presentation. So now you will see that we have gone through all these topics regarding surfacing and advanced design methodologies. So now I would like to thank you also for coming to the workshop, and I hope you had a great time. Let me know if you have any questions after this. Now I would like to hand over the stage to the host and let me know if anyone has any questions. So we can go through them individually. Thank you.
Thank you, Sir Ali. Thank you so much. Thank you so much for your time. It was a pleasure to have you. Now we'll be having a question and answer sessions. If you have any questions, please raise your hands or you can ask in WhatsApp groups. The first question we got, can we 3D print the part made by using surfacing?
Yeah, so as I said before, that surface modeling creates a part with zero thickness. So you either use it to aid your solid modeling process, or you eventually convert your surfaces to a solid body via knit command by enclosing the surfaces to form a closed shape and then knitting it and converting it into a solid body, or by giving it a specific thickness. So if you have converted your surface body into a solid by using any of those commands, then you can print it. Otherwise, you cannot print any part with zero thickness, because in real life, zero thickness actually doesn't exist. So you are only able to print the part which are solid. And if you create solids with surface modeling, then you can print it, yes.
Okay, the second question is, How do you incorporate advanced design methodologies such as generative design and topology optimization into your surface processes?
Like that can be used as a starting point to actually get an idea of how a part should look like. Generative modeling does not actually give you mathematical surfaces like a circle or a rectangle, a smooth surface. It is used as a starting point to see that what type of shape you are targeting for. And then after using generative modeling and topology optimization, you are supposed to manually model on top of it to make sure that your part looks like the one that is generated with the generative modeling process. I hope that answers the question. You're not audible.
Another question, difference between sheet metal and surface modeling.
Yeah, so sheet metal is specifically catered in sheet metal. The commands are specially catered for the manufacturing process of sheet metal that we know. It has the commands that are mostly related to the manufacturing processes in sheet metal that we face, like we can apply the K factor, we can have a specific stamping into the sheet metal, and we can have flanges, we can have reliefs. So that is more manufacturing oriented, and sheet metal comes with a thickness. It cannot be of zero thickness. You can convert a surface model into a sheet metal part, but sheet metal is specifically catered for the manufacturing aspect of the part, and it never comes without a thickness. So the first difference is that it always has a specific thickness to it based on what thickness sheet you are going to use. And the second difference would be that it is mostly related to manufacturing processes. And surface modeling is focuses more on the geometry that you are targeting.
As also have another question. How do you
Mhm.
ensure consistency and coherence across multiple components or products using surfacing?
Using surfacing, I think surfacing is not something to basically maintain the coherence of part along with different parts, but it can be in an aspect that if you mean by that surfaces fit into each other or not, then I would say that you have to cross-reference the parts into each other, like we have used the configurations and stuff. So you can make a specific surface, and then you can offset it to make another surface and use that surface to make the other part, the model the other part that is going to be fitted on top of the first part. So you will have to make cross references between different parts, or you will have to create a multi-body part so that you can make sure that there is a specific reference between those parts, so that if you make one part, if you edit one part, the other part also edits, and the offset commands can be used to define the tolerancing between how you are going to fix the parts with each other. And the detailed answer to this question would actually require me to model it and then show how these parts are going to fit into each other, and how you can use different commands to aid in the process of referencing the parts with each other. So the verbal answer will be that you need to reference the parts with each other. You need to understand where the tolerances are going, in which command you can use that you can easily apply the tolerance limits between different parts. But the detailed answer would require a lot more time and me sharing my screen and going through it. And that also requires using surfacing and then solid modeling in combination with each other to make different components. I hope that somewhat answers the question, but again, this question is quite wide, and if you want an in detailed answer, you can reach me out on LinkedIn, and I can personally cater for that question separately.
Well, ladies and gentlemen, this wraps up our today's session. I would again like to extend my sincerest gratitude to the speaker, Sir Ali, for being here and spending his precious time with us. The next module will be covered by Mr. Ahmad Ijaz on 28th February. Till then, Have a blissful day. Take care. Allah Hafiz.
Thank you for having me. And if any of the guests feel like that I was going too fast or I did not cover any specific topic completely, you can always reach out to me on LinkedIn, and we can like go into specific details of certain other topics that were inadequately covered or did not or were not covered in this workshop. So I hope everyone had a good time with me, and thank you to the host for having me in this. It was a great pleasure. It was a great audience, and I had a good time, and I hope you did too.
Yes, we did. Thank you. Allah Hafiz.
Thank you.